Welcome to Chapter 6, Page 5. We are talking about transforming and combining random variables now. But first, let me just show you how to do what we did last time on the calculator. Recall that the cars sold by my fraternity brother Pops are somewhere between 0 and 3 per month with these probabilities. Yeah, he's more likely to not sell very many. That's what's clear. But occasionally he does quite well, 2 and 3. You might not think that's quite well, but remember he was running the joints, so he didn't spend a lot of time selling cars himself. Okay, so how can we get our calculator to do this? Well, let's put these values in L1 and L2. Remember, that's stat edit to get to the lists. And then you're going to do, well, pause if you need to, but once you get those in the lists, then you can do stat calc to get to one variable stats. And you're going to tell it to use L2 as the frequency list. If you're doing this with an old calculator, you just need to put the L1, L2 next to it, and it will use the second one as the frequency list. Now, if you punch it in this way, you'll get a mean of 1.1, and it'll tell you the standard deviation as 0.9433. So that's what it tells you. Remember, the mean is the first one given. The variance you have to find by squaring, and if you square, it'll come out to 0.89. Suppose, however, that we want to calculate his monthly sales of cars, or monthly profit. Monthly sales profits. Okay, so he makes $800 per car. We want to calculate his monthly sales profits. So let's say he sells 0 cars. Well, he'll still make $0. But if he sells 1 car, he'll make $800. And that's going to happen 40% of the time. If he sells 2 cars, he'll make $1,600, and that will happen 20% of the time. If he sells 3 cars, that'll be $2,400 he'll make, and that happens 10% of the time. Okay, before you plug these into L1 and L2, let's do some predictions, okay? Take a moment to predict what you think the mean would be in terms of his monthly sales profit. Just note that we have a mean number of cars already. It's 1.1. So how would you take that mean number of cars, that's 1.1 cars per month sold, if he's making $800 per car? What's the average amount of money he's going to make per month? Now remember, this doesn't have to be one of those 4 numbers, and it won't be. If he's selling 1.1 cars per month, then $800 per car times 1.1 cars leaves you with $880. So there's $880. Notice how the dimensional analysis works here too, that you learn in chemistry. Let's predict the standard deviation. Remember, the standard deviation is the same units as the mean. And so if it's 0.9433 as the standard deviation, as you can see above, that's 0.9433 cars. So 0.9433 cars is typically how much his monthly sales deviate from the 1.1 average number of cars sold. So if it's 0.9433 cars and it's $800 per car, so it's $800 per car times 0.9433 cars, that is going to come out to 754.7, I believe. So 754.7, that's in dollars as well. That's typically how much his monthly sales profit will deviate by. Okay, what about the variance? Can you just simply take the old variance and multiply it by 0.89? The answer is no, you can't do that. recall that you need to square the standard deviation, right? You need to square the standard deviation. 0.9433 squared is 0.89. That's where it comes from. So we need to square this, which means we're squaring the 0.9433 again. That's where the 0.89 comes from. That comes from squaring the 0.9433. But we're also going to be squaring that 800. And so we end up with 569,572. That's what I'm getting. Right? Much bigger number than 800 times 0.89, which will be less than 800. So when we augment or compress, when we multiply the mean by a number and the standard deviation by a number, we need to multiply the variance by the square of that number. Okay, so let's put that in a rule. When multiplying each value in a probability distribution by some number b, the mean is multiplied by b. And the variance is multiplied by b squared. Okay, but let's say we want to calculate the total monthly income, not just based on sales, but income for his shop. And let's say he replaces the brakes on one car per month for $200, or this is totally monthly income due to his direct labor. So every month he replaces the brakes on one car for $200. What that means is even if he sells 0 cars, he will have an income of $200 because he'll have replaced the brakes on a car. And that, again, happens 30% of the time. For the 40% of the time where he sells 1 car, it's going to be $800 plus $200. He'll make $1,000 that month. And this should be total monthly profit, by the way. Not income, profit. Let's say he sells 2 cars. He'll end up with $1,600 plus $200. 20, and that's going to happen 20% of the time. And then if he sells 3 cars, that's $2,400 plus the $200 for the brakes. So everything moves up to $100. Let's predict the new mean for his sales. Well, he's making $880 per month on average by selling cars, and we tack on an extra $200 a month for the brakes. That means every month he should be making, on average, the $880 plus the $200, and that it will indeed come out as $1,080. Take a moment now to predict what happens with the variance and the standard deviation. What are your predictions? Remember, the old ones are up here. We've got a 754.7 and a 569, 572. What's going to happen to those? If you want, go ahead and plug these into L1. So change L1 so you can figure it out and watch what pops out. Well, what pops out is the same standard deviation, which means the same variance. Why on earth is it staying the same? Well, think back to when you first learned about variance and standard deviation. They are both measures of spread. When you add $200 to every possible data point, does the data spread out? No. All you're doing is shifting it up. You're not stretching it out or compressing it. You're just shifting it up or down. It's not going to change how much it's spread out. So the variance and standard deviation should stay the same. So when adding some number, which we'll call A, to each value in a probability distribution, the mean is increased by A, and the variance is the same. Variance is the same. You know, while we're here, I think it would be smart to quickly note up here that the mean put this in orange. So when you're multiplying, the mean and the standard deviation is multiplied by b, while variance is multiplied by b squared. But down here, when the mean is increased by a, the variance is the same, and so is the standard deviation. So it acts a little differently. We can summarize these in two main rules. If you know the old mean and you're multiplying by b and adding or subtracting a, then you'll multiply the old mean and then you'll add or subtract that shift. If you'll know the old variance, the new variance will be that multiplier squared times the old variance, and a doesn't have an effect on it. Similarly, if you know the old standard deviation, then the new standard deviation, after you've augmented and shifted, would simply be the augmentation times the old standard deviation. And a won't affect it, as we just saw. And that's it.